25th, a wire of uniform cross section and resistance 4 ohm is bent in the shape of a square A, B, C, D. Point A is connected to a point P on DC by a wire AP of resistance 1 ohm. When a potential difference is applied between A and C, the points B and P are seen to be at the same potential. What is the resistance of the part dP? So here this is the wire A, B, C, D. It is having 4 ohm resistance, so each side will be 1 ohm. This is 1 ohm. So, but A point is connected to DC as P at P, and this the resistance of this is also 1 ohm. So if suppose the resistance of dP part is R, which we have to calculate, then this part will become 1 minus R. Further, A and C are connected with some potential difference, and it has been found that if we connect a galvanometer here, B and D are equipotential, so that means this galvanometer deflection will be 0. So if we just try to find out this resistance, this is in series and this is parallel to this. So if we try to find out this, then we'll get a circuit like this. This is 1 ohm, this is A, this is B, this is C, and then this will become P. So this resistance is 1, this is 1 ohm, this is 1 minus R, and this will be, this resistance will be 1 plus R into 1 upon 1 plus R plus 1, because they are in series, so it is 1 plus R, and now they are in parallel, so this is net resistance R AP is equal to this much. So this is nothing but 1 plus R upon 2 plus R. So here we can write it 1 plus R upon 2 plus R. And now again connect this with battery, and this is the galvanometer. So this is nothing but the Wheatstone bridge. So as per the condition of the Wheatstone bridge, when this is null deflection, the balance point, so that means this upon this should be equal to this upon this. So 1 upon 1 should be equals to 1 plus R divided by 2 plus R whole divided by 1 minus R. So here we have 1 minus R equals to 1 plus R upon 2 plus R. So here 2 plus R minus 2R minus R square should be equals to 1 plus R. So this R will cancel out. So here it is 2 minus 1 is 1 minus 2R minus R square equals to 0. So we have R square minus R square plus 2R minus 1 equals to 0. So R will be equals to minus 2 plus minus under root 4 plus 4 upon 2. So the R will become minus 1 plus minus root 2. As R cannot be negative, so R has to be minus 1 plus root 2. That means 0.41 ohm. So the value of R is 0.41 ohm. And if it is asked, then this will be, then the RDP will be this, and RPC will become 0.59 ohm. Although this is not asked, but you can just get it. So the resistance dP is 0.41 ohm. 26th. The given figure shows a long straight wire of circular cross section, radius A, carrying steady current I. The current I is uniformly distributed across this cross section. Calculate the magnetic field in the region R is less than A and R is greater than A. So here we have the conductor like this, and a current I is passing through this. All over it is distributed. The radius of this is A, and we have to find the magnetic field induction at point this, where this R is the radius of that portion, and there is another point which is outside the wire or the conductor, which is again radius R. So this is A and this is suppose B. So in case A, the R is less than A, and in case of B, R is greater than A. Now here, as this current is uniformly distributed, so then current density J will be equals to current upon area, that is I upon pi A square. So current passing through the small cross section, that is the loop A, that time IA will be equals to J into pi R square, that is that is equal to I upon pi A square into pi R square. So that will be I into R square upon A square, that will be IA. Now according to Ampere Circuital law, B dot dl over the closed loop, this is the loop. So according to this, B dot dl will equals to mu naught IA. So B dl cos 0 to 2 pi r will be equals to mu naught IA. So here it is B, dl is L, 0 to 2 pi r, and mu naught I equals to I r square upon A square. So here this B will be equals to, BA will be equals to mu naught I r square upon A square into 2 pi r. So one of the r will cancel out. So we get mu naught upon 2 pi I upon A square into r. Now we can find the magnetic field induction at point B. So for that, according to Ampere Circuital law, again we get, according to Ampere Circuital law, we get B dot dl over the closed loop will be equals to mu naught IB. So here again B dl cos 0 to 2 pi r equals to mu naught IB. There is no current outside, so this remains same as I. So here B into L 0 to 2 pi r equals to mu naught I. So here B 2 pi r is equal to mu naught I. So B will be equals to mu naught I upon 2 pi r. So this is the magnetic induction at the location of B, I can say. So this is complete answer, this and this. If we can, just for knowledge, information, just see here the dependence of the magnetic induction is inversely proportional to the R. But here, what is happening? This BA is directly proportional to R. Initially, it will go on increasing till this R is equals to A, and after that, it will start decreasing. So here it is linear dependence, and here it is inversely proportional to the R. 27th, identify the part of the electromagnetic spectrum which A. produces heating effect, B. is absorbed by the ozone layer in the atmosphere, and C. is used for studying crystal structure, and write any one method of production of each of the above radiations. So here A, as far as A is concerned, the produces heating effect. So it is infrared radiation. Then B is absorbed by the ozone layer in the atmosphere. So it is harmful also. Then it is ultraviolet rays or radiation. And the C is used for studying crystal structure, that is naturally X-rays. Now the second part we can say of the question is write any one method of production of each of the above radiation. Infrared radiation, that is heating effect. So it is nothing but by heating method. So infrared radiation, basically you just go on heating the suppose हॉट बॉडीज से मिल जाएगा. आप किसी चीज़ को गर्म करें, आप एक घर में अगर तवा गर्म करते हैं उससे भी रेडिएशन आती है, गर्मी आती है. आप भट्टी पे देखते हैं वहाँ पर तंदूर की, वहाँ गर्म. तो ये बेसिकली मेथड इज हीटिंग इज द मेथड, और यू कैन से हॉट बॉडीज, तो वहाँ से इंफ्रारेड रेडिएशन आ गया. देन अल्ट्रावायलेट रेज देखेंगे तो हाउ दे आर प्रोड्यूस. हमारे घरों में, आपके घरों में बहुत सारे अल्ट्रावायलेट के जो है डिवाइसेस भी हैं. तो इसमें क्या करना है, नथिंग बट पासिंग करंट इन वेपर्स, दैट इज बेसिकली गैसेस, दैट इज वेपर मर्क्यूरी. तो यू कैन हैव वेपोराइज्ड mercury, or you can say the gases. This is the method to produce it. And X-ray is produced by bombarding high energetic electrons. High energy electrons on a certain target. Generally it is tungsten. On a target, that is tungsten is generally taken. So this is the method, these are the method for producing these waves.